Which of the following shows the numbers 2 to the half, 3 to the third, and 6 to the sixth in increasing order? And we're given a bunch of combinations, a bunch of orderings of these three numbers. Yeah, what might be the best way to do this? I mean, I'm thinking they're listed in decreasing order. That's my intuition, that 2 to the half is greater than 3 to the third, is greater than 6 to the 1 over 6. But, you know, I'm not positive. Maybe there's a way of figuring this out. One thing I might do is consider the function f of x is equal to x to the 1 over x. And either... And, you know, if I take a derivative of this and show that it's negative, I'd be happy, because then it means it's a decreasing function. That's what I'm going to start with. And if that doesn't work, if I can't conclude that the derivative is negative, then we'll think of something else. In fact, I don't really think I need to take any derivatives because I've just written this function in a different way, which clearly shows that it's decreasing. Okay, so ignore the negative sign for now. X is an increasing function. Log x is an increasing function. So as long as both of these are positive, if I have a positive increasing function multiplied by another positive increasing function, then the result will also be positive and increasing. And we're only worried about values of x which are greater than or equal to 2 here. So this is a positive increasing function of x. If I put a negative sign in front of it, it's then, of course, a decreasing function of x. And the exponential function is an increasing function of its argument. And so by putting in a decreasing function here, the entire thing will be decreasing. So this is that 2 to the half is greater than 3 to the third is greater than 6 to the 1 over 6. And that's option B. Written it in the wrong order, but that's fine. Yeah, so my intuition happened to be correct here. And I suppose we could, you know, even from this we could figure out that the sign of this thing changes when x is equal to 1. So that's where, you know, you'd have to figure out if this thing is, you know, the increasing decreasing relationship here changes when x is equal to 1. Oh, did I do this completely wrong? Did I define the function incorrectly? On x to the 1 over x. This is, e to the 1 over x log x. God. What a mess. It's been a long day. Okay. I think the answer is still correct because... is it? Log x over x, so this is increasing. That's decreasing. Oh no, so we might have to actually do something here. Let's compute a derivative of this now. Okay. Yeah, so I was wrong. I've computed the derivative here. That's positive, so I don't care about them. I only care about the sign of this thing. Okay, so the value of e is what matters here. I'm happy that I went back. I'm happy that I went back and tried to argue that there was a sign change of something at 1, because the number 1 doesn't look like it's special here, and yeah. Anyway, this is all wrong. So the function, the derivative is positive for small values of x, and then it decreases. It decreases when x is greater than e, and e is what? Approximately 2 point something something. So certainly, oh, well, this says that 3 to the third is greater than 6 to the 1 over 6, but it doesn't tell us where 2 to the half is. Oh my. Well, this might still be the right answer, the thing I had up there earlier. Okay, let's compare 2 to the half is greater than 3 to the third if and only if 2 is greater than I'm just squaring both sides, right? 2 over 3. That's if and only if I take a cube root of both sides. 2 to the 1 over 3 is greater than 3. Or sorry, 2. Here we go. 2 cubed greater than 3 squared. Okay, so this is false, right? 8 is not greater than 9. So we have 2 to the half is less than 3 to the 1 over 3. And I suppose we could now check, rather than using this type of analysis approach, we could do something similar to check that. This is if and only if 3 to the 6 is greater than 6 cubed. 6 cubed is what, 216? And 3 to the 6 is the same as 9 cubed, which is much bigger than that. That's like 700 and something something. Yeah, so oh, but then I guess we have to compare those two, don't we? Okay. Whoops. Two to the 6 is what, 64? Okay, so 2 is greater than 6. Well, 2 to the half greater than, this is the order. 2 to the half is greater than 6 to the 1 over 6. And this is less than 3 to the 1 over 3. Yeah, okay, so I hope that's one of the answers. Let's see if this corresponds to one of the options. Should go 6, 2, 3. Yeah, that's option C. All right. So yeah, my stupidity allowed me to arrive at one of the answers that was given. Again, I'm happy that I did some kind of brief check and something in my brain wasn't going wrong. Yeah, I mean, I've had conversations with some people who view the channel, and my sort of first approach is very often something analytical, where I try and use calculus or analysis on things as a first instinct, where that clearly didn't get us anywhere. And the sort of correct approach, or at least something that's a little bit more straightforward, kind of gets us there right away. I'll have to remember that. I've done a question similar to this a long time ago on another exam, and I also sort of ran into some roadblocks, but I'll have to remember just to rearrange the inequalities like this into something which can be easily computed. Yeah, so cool little problem. Little disappointed in myself that I got it so wrong so quickly, but that's how it goes. Thanks for watching.